Okay, so I told you that what is the significance or how you name the gaps. So let's discuss about the importance of different type of electrodes. Actually, these electrodes are proposed by the researchers. Okay, so this is the setup of the rod gaps. When you have the rod gap, this is the demonstration that in the rod gap you have the electrodes in the form of pointed edges. So rod gap is the cheapest method of high voltage measurement, and arc always forms at the center of the edges. So this is the actual lab image. Here you just apply the high voltage, and this is the insulator, and here this is a full controlled environment where you can measure the voltages, high voltages, because obviously we need the safety of our researcher who is working in the high voltage lab. So that's why this is the fully enclosed and sealed actual controlled environment where you are going to measure the high voltage. But this is the more sophisticated type of rod sphere gap instrument. In our lab we have a simple low cost instrument for just understanding of the typical low volt, like not too much high voltage, like up to 100 kilovolts. This apparatus shown is used for up to 1000 kilovolts. Okay, but now we will be discussing what are the drawbacks. Actually, since as we have that arcing actually melts the tip of the rod, so after some experiments this tip of the rod needs to be sharpened. It must be reshaped, it must be made pointed, because the pointed edge actually gets melted. And then if you have no sharp edges, then obviously the arc will not be straight, and hence your measured distance will be inaccurate, because here it's more important that the distance you are measuring must be accurate. So if there are no pointed edges and edges are worn out after too many experiments and they are melted, then in this way you cannot measure the accurate distance, because arc will be not straight. Okay, so error will increase. So in another concept you must be keep in your mind that in indirect methods, whatever we have the indirect methods, we have the maximum error of about 10% error. It can be minimum, it can be, but maximum it is the chances that error cannot be exceed more than the 10% in your measurements. So what are the drawback of the rod gap method? The drawback is that the pointed edges get melted. But it is a cheaper, obviously it is the cheapest form of electrodes, and you need to sharpen them again, reshape them for after many measurements, because you have to see if the edge is melted or not. Then one of the another method or another gap is the sphere gap. Here you have the conducting spheres, and this is one of the most accepted method and international standards. According to international standards of measurements, the sphere gap method is one of the most widely accepted method, because the results through this method are much more accurate as compared to other type of electrodes, because in the sphere obviously the arc will be producing at the midpoint, but spheres have no issue of worn out like that. So you can see this apparatus, you bring down the two spheres and a point comes that you observe the arc, and you stop down further displacement and measure the distance between the spheres. Now sphere gaps are accurate, okay, and internationally accepted, everywhere widely accepted, but what is the drawback? It is costly and research companies or research institutes have no issues of fundings. So you will be observing in your practical field work that whenever they will be deploying the spark gap method, they will be having sphere form of electrodes. Another type of the high voltage measurement is the plane gap method. Now in the plane gap method, you have the parallel planes or plates. Now this method is used, now you know that we have to measure either DC voltage or AC high voltage or an impulse voltage. When you have to measure the AC voltage or a DC voltage, high DC voltage, then sphere gap method is one of the best method. But if you have an impulse voltage, then for accurate measurement of impulse voltage, rod gap method as well as the sphere gap methods, they provide us with the inaccurate results. But if you use plane electrodes, then your results will be more accurate. Why this is happening? Because when impulse voltage is type of voltage which has a very less energy density. So impulse voltage has least energy density. If you have, and obviously impulse voltages are like those type of voltages which have the rise times in microseconds. If you are using rod gap or using sphere gap for measurement of impulse voltage, then what happens? Impulse voltage, instead of measuring it, will be there will be multiple arcs will be formed, and actually that will be an inaccurate method because sphere is not suitable for the impulse voltage waveform. And because why this is so? Because the impulse voltage rises in microseconds, and you saw the area under the impulse is negligible area, and and it's a very small area. You must say that area tends to 0. So for that type of waveform, your rod gaps or sphere gaps, actually instead of forming arc, they actually discharge it in a different way. But if you have the plane gap, in case of plane gap, the surface area is high. The surface area in the form of in this plane gap is high. So here when you apply the impulse voltage, only one arc will form, and you will measure the distance. But if you use the plane gap for measuring the non-impulse voltage, then multiple arcs will be formed. So again, we don't need multiple arcs to be formed. So that's why the plane gap method is used for the measurement of the impulse voltage waveform. So other type of gaps, here you can see a demonstration of the plane, as it is point to plane gap. Here you have the plane electrode, and here you have the rod pointed electrode. This is actually point to plane gap. Now point to plane gap has other significances why it is used. You can see here you have, this is the insulator in the brown color, this is an insulator, and here you apply the high voltage, and this is the very micro lab instrument which is used to measure the high voltages stored across the capacitors, and this is its complete diagram of this is the schematic of this type of sphere spark gap experiment. Okay, so there is another concept of air breakdown, the concept of air ionization. This is the field work experiment. What happened? We were interested in measuring the breakdown voltage. This happened in our lab. What we were doing, we were experimenting, or we established a setup for measuring the breakdown voltage of air in our lab. So we first measured that the breakdown voltage of the air is 17 kilovolts, because the first arc, because at first we saw that the arc was initiated around 1 centimeter when we applied 17 kilovolts, So what we did, we adjusted the distance to 1 centimeter and we started increasing the voltage. Or you may do another way, you apply a fixed voltage and you start decreasing the distance. But what we typically did in our lab, we first adjusted the rods we adjusted the electrodes 1 centimeter apart from each other and we started applying the high voltage, and we observed that at 17 kilovolts the arc initiated. Okay, we noted down. But what we did soon after that measurement, after 10 seconds, we just redid that, we reperformed that experiment. Now what happened, our rods were 1 centimeter apart from each other. So what we did, we started increasing the voltage and we observed that the arc was formed at 15.7 kilovolts this time. What could be the possible reason? The arc first initiated at 17 kilovolts, but now arc is initiated at 15.7 kilovolts. The same lab, same setup, just the difference of the time after 10 to 20 seconds or 1 minute. Yes, after 1 minute we reperformed this experiment. Let's think about it. What could be the possible reason? The possible reason is that because at first in our lab air had no ionized particles and air took more electric stress to break down. But after we conducted the first test, now we have the ionized air present in the surrounding. Now this ionized air did what? Now when the next time we applied the electric stress and we intended to measure the breakdown voltage, we observed that the air got broken down at less electric stress, because this time we have ionized air molecules in our lab. So that's why the presence of ionized air is also a factor of reducing the breakdown voltage of the air. And keep in mind, you know that air has the dielectric strength of 30 kilovolts per centimeter. But what happened is, the other factors were humidity and temperature, and this another factor of ionized air we observed. So once again, there may be a question arising in your mind that from this slide, that when we used to measure the breakdown voltage of the air, why 1 centimeter is fixed? Actually, what we did in our lab, we actually first adjusted this distance to 1 centimeter. We set the electrodes 1 centimeter apart from each other and we started applying the voltage. We started increasing the voltage here, and we observed that when the voltage across these electrodes is 15 kilovolt, we observed the spark. So we said that the breakdown voltage of air is 15 kilovolts per centimeter. This is how we observed the breakdown voltage. There is another method. You have applied the voltage, but you started decreasing this distance between the electrodes. Either you are moving the electrodes and kept this voltage fixed, or either you have kept the distance fixed and increasing the high voltage. But most generally in our lab work, you will be seeing that we will be fixing the voltage, we will be increasing the voltage to our level 1 to a certain level, and we will be decreasing the gap between the electrodes such that the arc is initiated. So both methods are right. You can use anyone, the either way. So here comes your assignment number 1, and in the assignment number 1 you have to compare the types of gaps in the spark gap method. I told you about some like plane gap method versus the sphere gap method, but you have to also compare the point to plane gap method, the rod gap method, the sphere gap method. You need to evaluate, you need to highlight, evaluate the pros and cons of each of the type. you need to highlight their typical applications where I didn't told you that where this type of apparatus is used, why it is used. I told you that this is the plain gap method and it is used to measure the impulse voltage, but I didn't told you about this point to plane gap methods advantages and disadvantages, about its cost. So you have to scroll the web, you have to scroll down the Google Scholar, you may study different research papers, and you have to prepare the assignment in the Word form and you need to upload on the Google Drive. I will be uploading as well the assignment box in your Google Classroom, where you will be able to submit your assignment. So you have a deadline of 1 week and you have to submit this assignment in the next week within 7 days. So this all ended with the part number 2 of video number 8, and in the next method we will be discussing the electrostatic voltmeter for high voltage measurement. Till then, study your previous lectures as well, and Allah Hafiz.